In the second section of our technical animation segment, we will be having a look at taking the first blockout from our animator and using this one to start to set up our secondary motion for the ears, trunk, and tail. We can always create this setup on a static stream, make sure it works as we intend to, make sure the flappiness of the ears or the trunk or the tail are in the realms of what we want to achieve, and then later on just swap the animation for the new one, which we'll actually show in a later segment where we do exactly that with the final animation and take it from there and tweak. But since we have the luxury of using the blockout of our animator already, we can just go ahead and do so. So I'm going to walk through the network really quickly. I'm not going to go super in-depth on the node itself, but rather the approach used for this particular scene. If you're interested in more details about the actual secondary motion SOP and its parameters, please read the documentation or check the Hive video we did that showcases exactly this aspect. So at the top of the network, we have our rig stash pose, so our classic sort of rest transform initialization here. The only reason we have it here as well as on the ragdoll side is because I've separated these into different geometry containers just to basically have it a better visualization of them as we go through. When we merge them, we're just going to be one. Then we have two attribute creates here. We see one for the right ear, one for the left ear. I'll explain in just a second why. Our animation comes here via an FBX animation output. Now the skeletons match. So this one is the same as the skeleton we have here in our FBX character import. So if we just do an attribute copy, and here we're copying our animation onto our skeleton just to keep this like rest transform and other configurations we've done. See that we're also copying the clip info here, and this is going to be useful for secondary motion nodes because they can just read from the clip info the whole range. It just makes it a bit easier for us to not have to worry about setting these for every node. And the clip info you can configure here on this tab. Then when it comes to the actual secondary motion setup here, now there are a few approaches that you can go down to configure something like this. I will explain very much what I chose to do for this particular scene and why. So let's start with the ears first, as these two nodes represent the ears. This is the tail, this is the trunk. So for the ears, if you're looking at this first node here, fire a state here so we can see the actual joints. The right ear base and left ear base are the joints specified here in the joint group that we want to affect. And then we want to drive them by the head that already has some animation coming in from our clip. So if we play just the normal animation, just gonna get the idea of, if you basically got nothing on the ears and the tail and the trunk, they're just completely static. The only one that moves is like body, legs, of course, and head and all that stuff. And we want to be transferring this animation from the head, which is very nice, to the ears. So basically get it for free, so to speak. So back to our setup here. We start with the ear base. Now the reason I separated these because as we see, the ears basically has a total of three joints really. The fourth one not really being skinned to anything. It's more about a guide than anything else. So three main joints here. We see here these 3 points are the ones that drive the ear. So these will be obviously the ones we want to be driving with the node itself. Now again, the reason I chose to separate the base from the rest, the other two, is more for convenience than anything else, because we are dealing with this parameter interface with a few options for each effect, including this effect multiplier here. It just felt a bit more natural for this particular scene to isolate this base first for both right and left, and that's why we have this attribute create, which I'll explain in just a sec. And once this is locked in and we're happy with the results, then move on to the other set of ear joints. One thing I want to mention here is that secondary motions can stack. So if we were to use for our ear mid here for driver, if we wanted to use the ear base, which would mean we would need 2 different nodes, right? One for right, one for left, because we have different driver joints. But if we wanted to do that, then we could, this would make much more sense, because at that point we're doing ear base first, and then with the result of the secondary motion, we want to drive the ear mid as well. So we get this stackable secondary motion setup. But for this particular example, it didn't seem like the proper path to go down to. So driving the ear mid from the head as well as the ear base from the head produced better looking results. So it's really more of a convenience of parameter splitting here, being able to modify these parameters and more freely without having to worry messing up the other joints setup. Another point here with the attribute creates is that you see we're basically doing right and left ear base in the same node, and we are doing this without splitting them into separate nodes because we have the luxury of driving our parameters using actual point attributes. So we see here we have the spring constant attribute and damping constant attribute with completely customizable names, of course, setting the mode to scale by attribute. So then if we come up here, we see we have exactly these attributes configured, spring and damping constant on both our groups for the left and right ear. And we set these values slightly different. So for this one, for the right ear is 1, so it's going to be 1-to-1 with the actual parameters on the node. For the left ear, it's 1.1 and 1.25. So we'll be getting a bit of that variation going through. So let's have a look at the result. We're getting this flappiness of the ears using those two nodes. What I just did with the modified place toggle, reason it was off to begin with, is because when we're chaining nodes like this, there's no point in keeping this turned on. It's just a bit of extra work that the node needs to do inside. So when you're chaining them up, it's enough to just toggle this on the last node in the chain. But we wanted to actually visualize the results here, so that's why I turned it on. So you can turn this off and then proceed to the next secondary motion, which is our tail. Now for the tail, it's not much to go on either. It's fairly similar, which we already covered. So we're just selecting all the tail joints here and the pelvis as the driver. And we set this to lag and overshoot, do a bit higher multiplier on the effect just to get more of a dramatic feel to it. And then if we play, we are getting this nice wiggle and waggle of the tail left and right. Very simple, very easy, really not much work that went in here, except of course a bit of tweaking of this effect multiplier. We can see that even the lag and overshoot parameters are just at default values. So it was a fairly simple and straightforward setup. Let me quickly go back to what it was beforehand, where it was completely static, and to what it is now, which is basically this nice wiggly. Notice also the nice propagation we're getting across the whole curve because, remember, again, we are using local transform, so we're getting this nice propagation for free. And then the last setup that we want to make here is with the trunk. Now for the trunk, I tried first to do this similar setup that we did for the tail, where we just select the whole like trunk. Actually, let's even go ahead and do that here, just so we get a more visual and clear understanding to why this didn't work just as well. So we can select our trunk joints here, and obviously driver will need to be head. And set to local transform, we can even leave the same parameters here. Now if we run this, well obviously this is, way too crazy, so let's set this to 1. But if we run this, we see that this is way too flappy. Even if we got this down to like 0.1, potentially could work, maybe a 0.2. Not terrible, 0.3 maybe. So you can definitely play with this and see if it's suiting your needs. But the idea here was that we didn't really want to have that much of a flappier motion on the trunk itself. Like it needs to be fairly stable and solid as the elephant's walking, and it would make sense that you would basically end up with motion from the tip of the trunk upwards. So basically the tip itself would kind of slightly move left and right as the head moves, and then the rest would kind of follow along but still stay fairly static. So this seemed like a very good fit in terms of workflow or approach to basically doing exactly that, but obviously transferring it to KineFX nodes, where what we're having here is we're using just the tip of the trunk as the joint and use the head as a driver. Set to modify position, so very important point here, not local transform. What this will give us is this crazy motion of the trunk that seems to be like all over the place and way too much. But once we apply this back onto the main trunk using a solver, like full body IK in this case, or a simple IK solver would also work just as fine. We are getting this flappy motion where we see it all stays fairly static, but the tip moves a bit up and down, and that just makes the whole trunk like readapt to it. So this is for this particular example, for this particular scene, a nice way to set this up in a believable fashion. We've got all the parts set up here now, so we can go ahead and use the new clip from the animator once we get it and replace it in here, as well as test our ragdoll and see what other adjustments we need to make to the configurations and setups we currently have in place.